primary structure. This is a kind of a term we call the sequence of bases primary structure. This particular sequence makes up its primary sequence or primary structure. It has a sense to it. I didn't write this down, but by implication, the fact that I wrote it this way is telling you that this is the 5' end, and this is the 3' end. How do we define that? That's based on where is an underivatized hydroxyl. So let's say this is just a short piece, even though it says it's cetera right there. Let's just say this guy ends right there with an OH. There's no more. This is one end of the molecule, that's the other. Well, which end is this? It's got an open hydroxyl at number 3. 1, 2, 3. So this becomes the 3' end because that's the open end. This end, the 3' end is busy connecting to this guy. The 5' side is the one that's open. So this is the 5' end, 3'. And you always write DNA sequences in that order. That's the way they're built inside the nucleus anyway. They're built in that direction. That's the way we write.
So on the board, how do you know?
It's just a convention that unless you specify otherwise, you are to assume that the one on the left is 5'. Someone could say, oh, I meant that to be the other way around, and I'll change that and I'll write it to be 3'. But in the absence of any information like that, if you can see that, the one on the left is supposed to be 5'. So sometimes you see it written this way with phosphates in between the bases, explicitly showing where they are. Because sometimes you might have a dangling phosphate on the 3' end, the 5' end, or 3' end. Usually not, though. Usually you just see it written this way. And you can assume 5', 3'. When you write it this simplest way, this shorthand way, without the phosphate, you don't know whether there's a phosphate on either end. You just know 5', 3'. Okay, that's primary sequence. That primary structure is, of course, the alphabet. It's the written archive of our genetic information. Those long strands of DNA in the chromosome. Just, miles and miles of this stuff, unedited code. This sequence spells out instructions on how to make proteins. So it's like our blueprints. And it's written in a language, obviously it's not English, but it's a language. It's a 4-letter alphabet. So we've got 26 letters in our alphabet. The DNA alphabet only has 4 letters in it. That was one of the arguments people used against this, and when they're trying to figure out what the genetic information was stored in. Like 100 years ago, people like Mendel had already done their classical experiment